Okay. Hello, everybody. Thanks for joining us. Well, today happens to be the 26th birthday of Mathematica, and what I really want to do is to show you the result of what we've been doing for all of that time. Many of you will have heard about the Wolfram language, and I'll talk a bunch about that here today. In a sense, the Wolfram language is sort of the culmination of what I've been building for 30 years or so. But what I really want to talk about today is the first new product that we're releasing based on the Wolfram language. It's part of a sequence of products, but the first one is here and being released today, and it's the Wolfram Programming Cloud. And what it's about the automation of programming. It's about bringing programming to kind of a new level, and it's about using the cloud to do that and deploying programs that you create in the cloud. Well, it's sort of a huge technology stack that allowed us to do this, and I'm going to sort of show you a variety of parts of it today. So let me show you kind of the most easiest way into it. Just walk up to any web browser, go here, go to the Wolfram Cloud, go to the Programming Cloud. Here we go. This is just ordinary web browser. Go here, say, create a new notebook, and now we should be live, and we're now talking to the Wolfram language and able to do computation. So let's try and do a few things here. Maybe we can say something like, make graphics of a sphere. Now we'll get something here that we can go and rotate around and so on. This is all happening right inside our web browser. Maybe we can try something a little bit more ambitious. Let's say we want to manipulate 3D graphics of, let's say, a couple of different spheres. So one at 0, 0, 0, and another one, let's say, at position R, R, R. Let's start off with that R being 0, and let's say go up to 4 or something. So now we will have created, here we'll create something which is an interactive object. Now, every time we move that slider, we'll actually be going back to the cloud to say, give us the updated version of this. Now, I might say that we could take this, let's just name this something, I don't know, testing 01. Now, if we want to, we could just take this and we could peel it off, I hope, and be able to get the exact same thing that we just did there in the cloud, we now have here in the desktop. The desktop, we have sort of a different set of trade-offs, but we can go ahead and just interactively move these things around because now we're operating with local computation rather than having to go to the cloud. Doesn't really matter whether we're in the cloud or on the desktop. Let me go back to the cloud here because it's the new thing. I could go and I can do all kinds of things. Now as I say, I'm just interacting with the Wolfram language here. I could go and say, give me a random graph like this. But now I could, I'll get the result. Now, kind of the idea of the Wolfram language is build in as much as possible. Sort of the traditional notion in computer languages has been keep the core language small and perhaps have libraries that add on to it. The notion in the Wolfram language is build as much as possible into the language, as much knowledge about computation and about the world as possible. Create kind of a knowledge-based language where you can sort of start from a basis of knowledge in everything that you do. So, for example, here we could go ahead and could do some computation on this plot and get the result here. There we go. Now we could, this is, again, all working inside our web browser. Now, the kind of the notion is to have all sorts of different kinds of computations built into the language and to set things up so that it all just fits perfectly together. So, for example, we could take that and we could, let's say, apply image processing to the image that we got there. Even though what we had was a graph, we can apply image processing and so on. Well, we got all kinds of things built in. Like another thing we might look at is machine learning. So, for example, we can say, let's classify a piece of text by language. And here it's telling us, okay, that this word with the built-in classifier that we're using for machine learning here, this word it thinks is in French. Okay, maybe we'll try something a little bit more ambitious. Let's go and let's try something with Gary here. Let's go, and I'm going to guess that the front page of the UN website probably has things in a bunch of languages. So let's go and read in, try and import the plain text from the United Nations website. Okay, there we go. Now maybe we can try pushing the string at new lines. Okay, there we go. Now, for example, we might say, let's go ahead and see if we can do language classification on those different languages there, so that it can figure out the answer to that. Okay, not bad. So I think the indeterminate came from the space there, which couldn't figure out what language that was supposed to be in. So okay, well, one of the features of the Wolfram language, in addition to having lots of computation built in, it's also got lots of knowledge about the world built in. It's the giant knowledge base that we've accumulated for Wolfram Alpha is now available in the Wolfram language. So we could go ahead and say, where does it think we are? Okay, that's based on my web connectivity. It isn't actually where I am, but it's what it thinks based on web connectivity. We could go ahead and say something like ask for sunset, and now it will compute what will the sunset be at that current geolocation. Or, for example, let's say we can go ahead and do a computation in which we start off from where we are, and let's go ahead and try and make a map in which we do something where we're creating a disk of radius 5 miles around the current position where it thinks we are, and let's go ahead and make a map based on that. And now this is all running in the cloud. It would be a little faster if it was running on the desktop. Here we go. So there's a map of where it thinks we are right now. Actually, perhaps we can, if we wanted to, we could go and do a computation here in which we do something where it's like a powers of 10 thing where we say we use the function like power range. We could say go from 1 mile to let's say 10,000 miles, steps of 10. There we go. Now we could go ahead and say something like this, where we say there's a quantity here of miles, and we can go ahead and make these graphics based on those succession of different distances. Let's see, maybe it'll take a little while to figure this out, but we should get a sequence of maps from this. Okay, but sort of the big picture of what's going on here is we've got all this knowledge that is built into the language that we can have access to in a completely programmatic way. So, for example, we can go ahead here. I'll tell you what. While it's thinking about that, let me go back to the desktop here, and I can go and do some other computation. So, for example, let me say I want to know about some. Oh, there we go. So here we've got all of those maps, from the very short-range map to the very long-range map. I guess 10,000 miles is enough to get almost all of the Earth. So we only have a small spot around Australia left over. Okay, but we can go ahead and do all sorts of computations here. Let's say let's go on and do something else with geographic data. For example, let's ask it about Mount Everest, and here we're using natural language to specify these kinds of entities that we're talking about. Now, if we want to, we can say, for example, I want to make a picture of the terrain around Mount Everest. So what I would want to do is I would want to take geo-elevation data. I would want to take some kind of bounding box of a disk around Mount Everest, and let's say it's a 5-mile disk around Mount Everest. So there I say 5 miles. There's this bounding box. Okay. So now what I would do is this will go and figure out where is Mount Everest, make a disk around it, find the bounding box for that, extract, get geo-elevation data, and there's the results for the terrain. Now, for example, I could make it a little bit more beautiful. I could start adding various options to this. I could say, I could add something. There we go. There's a convenient autocomplete there. I could like fill it down to the bottom of the picture, and I could go ahead and make, let's say, rainbow color function. So there, I've got the result. So again, this is using all of this knowledge that's that's built into the Wolfram language. Okay, well, the next question is how do I take all the stuff that I'm using kind of interactively here, and how do I actually use it to create deployed programs, for example, in the cloud? Well, it turns out to be very easy to deploy to the cloud. So, for example, I could just say here, I could, for example, let's just deploy something very straightforward. Let's deploy the word hello in 40-point type, and let's just say deploy that to the cloud. And by the way, I could do this just as I could do this equally well here. Let me instead of doing that on the desktop, let me go ahead and do that in the cloud. Exact same thing. I can do this. Now I'll get a link there. and now I'll get this new web page that was created that just says hello. So now here, I can go ahead and say, for example, let's say I want to adjust this and I want to say deploy that. I want to export it as a PNG and I want to rotate it by 70 degrees, for example. Okay, so I can just do that and I say rotate that and I say export that as a PNG, and now I can do the same thing, and now I'll get back a result here, and then there's my result. It wasn't, I didn't tell it to make it bigger. There's my hello rotated by 70 degrees. If I wanted to, I could actually make this a dynamic thing. So, for example, here I could go ahead and say, I could go ahead and just export this with an angle theta here, for example, let's say in degrees, and I could go ahead and say, make this anything between 0 and 360, and now I could go ahead and deploy that to the cloud. So this will now create something which in the cloud, I hope, is has a, oops, I made a mistake here. What I did was I deployed it just as something which would be private. If I wanted to, I could say permissions to public, and now that particular URL will hopefully create something in the cloud here that now I can move it, and I'll get this kind of interactivity here in the cloud. So what we did, and maybe I can let me just add something here. For example, let's say I add a color here. Now I can go ahead, let's say color red or something. Now what we should get, same kind of thing, but instead it will have added a control, I hope, that not only lets us adjust, but also lets us change colors and so on. So, okay, so that's deploying something like that. What if we want to deploy a something like a form to the web? Well, that's really straightforward. I'm just, for a change, let me do that from the desktop. So what we do there is we just say we use a thing called a form function. This is a symbolic construct. And for example, we could say something like, I don't know, let's say we know, cats are popular on the web. Okay, so let's say we have, we say we're going to have a form and it's going to have a field, and that field is going to look for a cat breed. And now we want to say, take the results from that field and show an image of that. And let's just make it a nice big image, and let's make that a PNG. And now let's say cloud deploy this. And now what we should get, we do that, and we should again get an object in the cloud here, which is now a form, and we can go ahead and we can type some name into this form. Now what's important, this is a smart field, which means that it's making use of the natural language understanding stack that we have. And so we could type some natural language name of a cat breed in here, and then it will go off and compute for a while, and then give us a picture of that particular kind of cat. We could try and do something a bit more ambitious here. For example, let's say let's take our image of Mount Everest here, and let's go ahead and do something more elaborate. Let's say we'll take this, and let's see if we can deploy this to the cloud. So what we'll do, let's make it a manipulate, and let's make that manipulate be something that has, let's see, a different, let's just make it be able to be a different height here, and go ahead and change that height from, let's say, between 0.1, let's say default of, let's say, 0.4 or something, let's say between 0.1 and 3, let's say. Now, then what we'll do, so then what I want to do is instead of saying the specific mountain, Mount Everest, let's call it a mountain called M, and let's make there be a form function in which we say we're going to type in a mountain, and let's have that be looking for a mountain. Let's here we have to say make that use the field, the mountain field that we got from the form. Let's now go ahead and tell it, okay, let's say, and now we want to go ahead and cloud deploy this to the cloud. Okay, so now hopefully we'll get something where when we deploy this to the cloud, look there, what have we created? Hopefully we will have created a form where we can say something like, let's say Mount Fuji instead. Let's try submitting that form, see what happens. I made a big mistake here. I need to tell it in what format I want to produce this output, and I want to tell it there that I want this to be in HTML. I think that's right. Actually, let me say Cloud CDF. I think that's probably a better thing to do. Let's give this a try. Okay, let's try Mount Fuji again, and with luck, we'll be able to make this work. Come on, wake up. There we go. Okay, so here's a picture of Mount Fuji, and we should be able to adjust the height here, and we'll get an accentuated Mount Fuji. Well, I think this is pretty impressive, that you can go from that in just a few, just a very short time and a small amount of code, we're able to get something like that deployed on the web. And by the way, I could equally well have added a little thing here that will take the result, output it in 3D printing format, and call an API to go and send this to a 3D printer. Okay. Well, now in addition to being able to make things like forms on the web, you can also you could, for example, make a dashboard. So, for example, I could go ahead and I could say something like, let's say I want to work out the time until sunset from now. So there's the, I've got sunset minus now, there's the time, and now let's say I want to unit convert that into, for example, seconds, then I should get the number of seconds here. And now let me say I want to deploy that as a dashboard. So let me go ahead and say cloud deploy. And now what I want is a delayed web page that will show that result. Let's do it in, let's say we want to do it as a great big thing, size 40. Let's say we want to do that in HTML. And let's say we want to do an update interval of, let's say, 0.5 seconds. So now we can cloud deploy this. And what we should get based on, okay, is we should get something which will start counting down in seconds, assuming that we can, that our web connection is fast enough. It will count down here and show us the result as kind of a dashboard. Okay. Well, we can also go ahead and make that into an API. So, for example, if I want to get an API for the number of seconds to sunset at the present time, all I have to do is say API function, and actually, let me do that for a particular location on the Earth. So let's say I want, I'm going to call it lock, and I'm going to have that represent a location, and I'm going to make this into an API function. Now I'm going to say this, and I'm going to say I want to actually just get the number out. So I would say quantity magnitude of that, and then what I would do is, see, for the location, I would say in here, I would say hash location, and this becomes a that. And now I can go ahead and cloud deploy this. And now what I'll get is a RESTful API that I can call in the cloud. So if I click on that right now, okay, it'll just give me an error message because I didn't give it a location. So let's say I've given a location lock equals, let's see, I don't actually know how to do quotes in this. Let's try, well, let's just try Chicago here, but I could as well have typed in the name of a monument if I could have thought of a one-word monument here. Okay, and there's the result, which we can then feed into another program for the number of seconds until sunset in that particular location. Well, actually, if I want to call this from a program, one of the useful things that I can do is take that API function. It's just a symbolic API function here, just a symbolic construct, and I could say, give me the embed code to embed this API function in, for example, a Java program. So I could go ahead and do that. By the way, I could have told the API function to return not some literal thing, but instead, let's actually, we can go ahead and do that. Let's have it return JSON, for example, instead of, so there we can just say return JSON. And now if I go here and I type in, okay, oops, that it was returning JSON, and it told me that the thing didn't have any parameters. So now I can say location equals, no, let's do Chicago again. Then it will give me, instead of giving me, okay, that JSON wasn't very exciting. It will give me a result in JSON format. Okay, but here I can go ahead and say, give me this API function, give me the embed code to use this API function inside a Java program. So there's the result from that, and now I can copy paste this into a Java program, and it will go ahead and call this in the cloud. I have to say that one of the things we have coming is not only the ability to call from an API function to call into the cloud, but also the possibility of calling into a local Wolfram Engine server or even an embedded Wolfram Engine. All of these things will be quite seamless. From the programming cloud, you'll be able to create code that will deal with calling out either to our public Wolfram Cloud. It will be possible to get Wolfram private clouds within an organization, or to actually have a local embedded engine. Okay, so that's sort of a quick sketch of some of the things that we have here. The full Wolfram language is a big thing. There's about 5,000 built-in functions in the Wolfram language, handling all kinds of different areas, whether it's engineering data, or whether it's 3D geometry, or whether it's making some nice kind of visualization, or whether it's interacting with the outside world and dealing with a sort of curated collection of APIs that we have, or whether it's generating documents or whatever else. I might just mention that one of the things that is not in the, well, one of the things that is available in the language is the ability to do arbitrary templating. So, for example, within these notebooks, you can have any kind of mixture of text and formatting and code. So, for example, here I could say the heading and then put a date string in there. This is now a template notebook that can be run to actually generate final output. So if I say generate here, it will run that and insert the current date. And I could as well be running against some database or some such other thing and create a nicely formatted report, even potentially an interactive report. And I could do this if I wanted to. I could do it through an API. I could do it in a scheduled way, and so on. So here's the whole Wolfram language, which is about a 5,000 function thing. One of our objectives is to have this language be as easy to learn as possible. So one of the things that I thought we should do is have kind of a fast introduction for programmers. And I was interested to see just how long this would need to be. It's remarkably short. You can find this here on the web. And once you've gone through this fast introduction, which shouldn't take very long, you'll be in a position to basically read any Wolfram language code. And at that point, you can go into sort of the mode of expanding the vocabulary and go and look at the actual Wolfram language documentation. There's about 100,000, maybe between 100 and 200,000 examples in the Wolfram language documentation that you can then use to explore different particular areas of functionality. Well, and once you are actually using the language, one of the very important things is that the language is completely symbolic. So every fragment of code means something, which gives one a very powerful way to build up programs in a modular fashion and to make it easy to debug things and so on. Also, that symbolic character is really what makes possible this whole flow from broad computation through real-world knowledge to the cloud. This kind of concept of symbolic, of having symbolic representations of things is critical in being able to sort of knit together all those different areas of functionality. Well, okay, so we're pretty excited about this because the way we see it, it kind of completely changes sort of the economics of programming. It used to be the case that to do something like, create that form that I made of mountainscapes for different mountains, that was a lot of work. That was something that would take somebody going and finding the data and using some graphics system and maybe putting this into Mathematica and then generating the output and all those kinds of things. And maybe then you'd have to have a form, and you'd say, well, how would I specify mountains in the form? And then you'd say, well, let's use a canonical mountain identifier. Where are we going to go find those from? And so on. But now what we've got is something where it's just that tiny little piece of code, and it takes us only a few moments to get to the point where we can actually do this computation and deploy it to the web. And I think this is pretty exciting because it means one can go from sort of an algorithmic idea to a deployed production thing on the web in an incredibly short amount of time. And one can also take the things one's deploying on the web whether they're forms or API functions or whatever else, and one can knit those into a full production environment. I should say that there's a powerful mechanism that exists in the Wolfram language for doing things like XML templating so that you can take some sort of ambient production environment and easily slot in the kinds of things that you're getting from the Wolfram language. So the thing that I think is really quite dramatic here is that we've really gone from something where programming, for example, something like this, was something that was hard, involved pulling all these pieces together, to something where within the language you can now just, and using the programming cloud that we're releasing today, you'll be able to just sort of walk up to a web browser, log in, start writing this code, deploy to the cloud, and you have a production application all constructed right from that. And I'm going to be really interested to see what people can do with this. It's something where our strategy is to have it be the case that people can get started completely for free on the web, and then they can even do some deployment on the web, so it kind of get it to the point where you can do your first demo of your new startup directly there on the web from the Wolfram Programming Cloud. When you're actually going to go into production and you're going to get serious teams of programmers and so on, then you start having to subscribe, and there's a whole mechanism for cloud credits and so on that allows you to scale up as large as you want. And as I mentioned, when you really want to scale up large, there is a private cloud option that will allow sort of arbitrary scaling along those lines. So I think that's about all I was going to say, and I'm really keen to have a discussion and get questions and so on. But this is that's an outline of what we have, and it's all live now on the web. You can just go to wolframcloud.com and start logging in. There'll be a bunch of announcements going out in a few minutes about all of this. So maybe we should turn this over for questions. So let me see. I'm looking at some questions here. If I can get my thing that shows me questions to be large enough that I can actually see the question. Okay. So first question here is, what's the most efficient and effective way to get started with machine learning and data science type functions given no mathematical experience? Okay, I think the best path in is look at the fast introduction for programmers, and then start actually trying to do real things. Go to this section on data manipulation, and maybe just go to the machine learning section here, and maybe just start in and look at the examples. I think one of the things that is remarkable, really, programming is an activity that is increasingly something people do from examples. But the Wolfram language is kind of an ideal case to do programming from examples, because the examples tends to be very short, and it tends to be easy to read the code. I think that's a real good place to get started. Pick a real problem and start doing it, and just find the functions you need. You'll have the sort of the basic ideas down if you've gone through this fast introduction for programmers. I would say that we have some training courses that we have. I'm actually not completely familiar with all of them, but I'm sure that there's one on data science, and that would be a good place to get started. Okay, I'll tell you, as a matter of fact, one way that in the future may be possible for doing this is I've been very interested in the problem of kind of programming education, and one of the things that we've noticed with the Wolfram language, we're in a very interesting situation where we kind of have a convergence between kind of the language that the most sophisticated professionals use and the language that sort of kids can start to learn. And that's sort of a very interesting convergence. It's happened in lots of areas like video editing and things like this over past years, but now this is happening with programming. And so I've become very interested in just how does one teach programming? How does one teach people to become literate in all these different areas and all these different ways to use computation? And so I think I'm kind of backing myself into creating some kind of course about sort of computational thinking that will go over kind of how to think computationally and how to actually use the Wolfram language and programming to achieve things computationally. And certainly one of the things that I will talk about there is machine learning and data science and so on. But that's in the future. For now, the documentation is a great place to start. Okay, next question. When will private cloud be available, and how much will it cost? let me go to a page that, let me go to the home page for the Programming Cloud here. Oh, this home page is now going to show me that. Let me go back. I want to go and actually go to the Programming Cloud page here. If I go here, I can at least show you. There we go. So this is the basic pricing model. There's a sequence of subscription levels, and with each subscription level, you get differing amounts of cloud storage and use on the cloud. At the developer level, you get something that I think is really nice right now, which is that you get the Wolfram desktop, so that you can do development either on the cloud or on the desktop seamlessly. And you'll get sort of that version of the desktop is one that just saves its files to the cloud. At higher levels, you will be getting also full desktop with the ability to do completely offline development as well as online development. As far as the private cloud is concerned, what's interesting here is that there's when you're dealing with cloud services, there's a sort of a whole combination of different things that end up costing money and that one ends up paying for. So in the usual case, one's paying for cloud credits effectively, 1 million credits for $180 apparently. Sounds like a pretty good deal actually. As a CPM rate, that's remarkably low. One credit buys you a small amount of CPU time. So when you are dealing with a private cloud, the charging model is somewhat different, and it's more by the core rather than by the cloud credit. And so it's a slightly different model. And I'm not going to embarrass myself by quoting a bunch of prices because that's not my specialty, and I'll simply get it wrong. Okay, there's a question here. What if you need transparency to verify details using the computation and the type of computation to understand what's been done for you? So the place where that shows up most is in data, where people say, where did that piece of data come from? And we have a whole mechanism for being able to drill down to find sources of data. There's sort of a computable mechanism for doing that, where you can actually get to a link from within the computation if you want to. Realistically, not that many people will do that, but it's something if you want to, you can do it. As far as an area like machine learning is concerned, well, if we go ahead, for example, and we say, let's go here, let's go and look up machine learning classifiers. Okay, so the typical thing that happens here, let's try and get an example here. So here's an example of a machine learning classifier. This is a digit classifier, and what we'll see happening here, we can just run it in the documentation here. Let me just go and make this a little bigger. So we can just run this, and what we'll see is that what it generates as an output, it says it's a classifier function, and the method it's using is logistic regression, and that's kind of the information about what's happening. If we wanted to, we can say, I think we say classifier information of that, and it will give us a whole bunch of information, and we can go and drill down and ask for excruciating levels of detail if we want to about exactly how this is being done by the machine learning system. I think machine learning is a hit and miss kind of thing, and we've got some pretty nice state-of-the-art stuff in here, and sometimes it will work, and sometimes it's just not something. You'll end up with a problem that just isn't one that machine learning can deal with. Here's a cute example. This is something where we're just interactively, as I draw a number here, it's showing the probabilities on the right for what it thinks my number is. So if I try and draw a 6 here, okay, it'll finally home in on the 6. So that's a kind of an example of seeing what's going on there. Can I show mobile? That would be a challenge because I have to, let me see whether I can show anything with mobile. This may or may not work, but I can try. Just because this is a real life thing, I'm going to, let me see what I can do. Let me see. Let's see if this will work. I have to, there we go. Okay. If I'm going to show mobile, I have to show a mobile device. Let's see. There it is sitting on my desk. There's an iPad. Oh, this is very amateurish, isn't it? Terrible. Okay. Let's see. There we go. Okay. So now let's go ahead and hit the Wolfram Cloud app here. Oh, this is going to sign into a different account. That's kind of annoying. Okay. Oh, well, so close, but it didn't quite work. What you will see if you do that is you'll see from within the Wolfram Cloud app, any of those forms that I was deploying will just show up as forms in mobile. And what's interesting is those forms will get interpreted for mobile. So, for example, if I requested an image in one of those forms, it will go to the thing in mobile where it's getting something from the live camera or from the photo gallery or whatever else. And in addition, things like all the geolocation stuff will all flow through from the mobile device. You can also, if you want to, from when you do a cloud deploy, you can go ahead and one of the options is the icon rules, and icon rules is a way to specify for all these different kinds of mobile devices what icon you want to show up for your little mini app that you're building. Now, on some environments like Android, you can actually use embed code to create from a form function. This is not available quite yet, but will be soon. You can go straight from the form function, create with embed code a complete Android app that you can then compile and run as a standalone app on your Android device that will then call into our cloud to get its computation done. Yeah, so you're asking about deploying a mobile app. It's as simple as just saying, once you've cloud deployed from within, what you'll see is in the mobile version, you'll see let's see, under deployment here, there will be something that goes to form-based mobile apps, and then that will show up on the home screen inside the cloud app on iOS, for example. On Android, you can actually have it as a standalone app immediately. On iOS, there will be an SDK available to create a standalone app, but it's a somewhat more complicated process. But basically what will happen is you'll see it just show up on inside the cloud app, and then you'll be able to click it and make things happen. Those are unnamed cloud objects where the icons are being guessed based on the content of the cloud objects there. What is the lifetime of cloud deployed artifacts? Okay, that's a good question. Do you have to remember to delete all your interim attempts when you produce the final version? Okay, so if you have a real subscription, then your cloud objects will live forever. And in fact, you can go ahead and go to the dashboard, and this dashboard will show you what cloud objects you have, what's been deployed, how often they've been visited. Okay, so this account is not really a real account, but this is showing me all my various cloud objects. Let's say instant web forms here. Let's go ahead and look at what I have there, and this will be showing me everything that I've deployed, and I can go and see what's happened to them. Actually, it's an interesting issue. What do you do with sort of cloud garbage? How do you get rid of cloud garbage? Good question. Something to think about. Probably we should have some mechanism for pruning these things based on them not having been used much. Okay, next question. Will the Wolfram Cloud allow for collaborative programming? The answer is, in its current form, it's actually quite that works quite nicely. You can go ahead with File, and you can just change the access here, and you could say I could add somebody's email address here, and I could say yes, they can edit it, or no, they can only read it. If you set it to be able to edit, you'll be able to go back and forth seeing differently edited versions of the file. We don't yet have a mechanism to let you actually see characters being typed. We may add that. But right now, you can absolutely do things collaboratively at that level. It's also an interesting thing. One of the things that we actually have coming soon is the mechanism we call our data drop. I'll be talking about that soon. But that's a mechanism where, for example, it has its primary uses for connected devices, but it will also have uses in things like classroom settings where every student can trivially push something into the data drop, and then a teacher can immediately and perhaps dynamically retrieve things from the data drop and show results, show sort of aggregated results. Okay, the next question was, are there Objective-C bindings? Let's see, embed code environment. Let's see what there is. So there appears to not yet be Objective-C. That's something which will surely be coming because, in fact, I'm surprised it isn't here yet because we have internal uses for that all the time. I should say one of the great features of having the Wolfram Programming Cloud in the cloud is that easy for us to continuously update it. For Wolfram Alpha, we've been for the last 5 years doing more or less one update a week, and you'll see the same kinds of things happening with the Wolfram Cloud. Can you give us an idea when you plan to deploy Data Science Platform and Mathematica 10? Mathematica 10 is very, very imminent. What I'm showing you here in the Wolfram Programming Cloud is actually running completely on top of Mathematica 10 type technology. The version of the Wolfram language that I'm showing here is precisely what's inside Mathematica 10. So Mathematica 10 and its online version are extremely imminent. The Data Science Platform is a little bit further away, but not too far. You can already see here many of the features of the Data Science Platform. Actually, okay, so here's a big secret. I actually have a switcher here, and I could just go ahead and switch to the Data Science Platform up here, and we'd actually be seeing at least the current state of the Data Science Platform. So it's quite imminent, and a lot of the technology is already here in the Wolfram Programming Cloud. It's just differently factored and differently deployed in the Data Science Platform. Okay, so the next question is, can developers share their code with other users? Is collaboration supported? So as I mentioned, when you deploy a cloud object, there's a pretty elaborate, actually, permissions mechanism. So if I ask about permissions here, you'll find, okay, so here are the details of the permission structure, public, private, a Unix permission string. You can also specify a collection of users to have all sorts of different kinds of access to a cloud object. So there's pretty fine-grained control over what people can do with cloud objects. Can they just execute them? Can they edit them? What can they do with them? So that will allow many forms of collaboration. One thing that is coming, not here yet, is the ability for people to create instant APIs and other apps in the Wolfram Cloud and sell them in a marketplace. That will be coming in the not too distant future, essentially an app store mechanism. Next question is, will Web Mathematica be replaced by the Wolfram Private Cloud? The answer to that is yes. The Wolfram Private Cloud is really sort of spectacular upgrade to that technology. Will we release a Wolfram Workbench Cloud version? The answer is yes. Wolfram Workbench will be able to interact with the Wolfram Cloud. I think that's coming quite soon, actually. I should say that one of the important things in the desktop is you see a line here that says open from the Wolfram Cloud. And so what you'll see here is a cloud file browser that will come up that will allow us to open files here directly. We're now looking straight at the cloud file system in the cloud, and the exact same mechanism will exist in Workbench. Does the Wolfram Cloud provide a way to persist data within the cloud environment? Absolutely. Every cloud object you deploy is persisted in the cloud environment. In addition, all of the documents that you're working with here, these are stored in your cloud file store, and they are completely persistent there. If you're asking about whether there's a fine-grained way to persist things in the cloud, yes, there is. I mean, any cloud object will persist, but I can also do something like I could say, for example, cloud symbol of X equals 89, for example, and now I will have something where that's now stored in the cloud, and that is a completely persistent thing. And if I go, actually, I'll try something I've never tried. I'm going to try something I've never tried. I wonder whether this works. Let's see. If I say cloud, oh yes, isn't that spectacular? So I created in the desktop and a completely different in the cloud environment there. I was able to do that. So for example, I could say here, something that I wonder if I can do that. Not sure if that worked. So yeah, so now probably I can go back and I can say in my other environment here, I could say, what's that cloud symbol now? And the answer is 90. So that's a very fine-grained way to persist information. Obviously, you can have documents. You can have, I should say, you can have documents that aren't just Wolfram language documents. You can have all sorts of kinds of documents there. You can be editing your JavaScript code and so on. You might want to do that because you might have, for example, an HTML file that you're actually using XML templates. So if I look at XML templates, XML templates are a mechanism for taking for creating. You can have an HTML file there that is templated, so that you can then slot it in to deploy something through the cloud. what will be the path to convert a commercial application developed with Mathematica 9 and running under Player Pro to the new cloud platform? It will probably, depending on the details of what it's using, it may be incredibly trivial or slightly less trivial. It is likely that you can simply take the CDF and deploy it as a cloud CDF, and it will just work in the cloud. Okay, the next question was about Mathematica 10. The answer is that the Wolfram language is sort of our base technology for everything, and yes, it's a little bit out of historical sequence here. The Wolfram language that we have here is kind of, you're seeing the future of Mathematica before it happens, so to speak, here. So it's a little confusing, but the issue for us is we have a very large number of products in the pipeline, all interdependent on each other, and there's no total ordering that makes sense in releasing these products. Are we releasing the Wolfram language on the desktop today as well? The answer is yes. The version, we're actually, there are two versions. One is one that looks only at the cloud file system. That one is being released today. The one that allows completely offline operation will be available in a few weeks. The technical difficulties there have to do with the way that authentication works, not the actual operation of the system. Okay, can one link and deploy CSS and JavaScript at the same time as pieces from the Wolfram language are deployed? For example, for doing reports and embedded forms and so on. The answer is yes. As I've been saying, it's very easy to do templating. Now let me show you something else here. Within this on the web, in the cloud document, let's see, we should be able to say embedded HTML, let's see if this works, of, let's say URL, and let's say, it's a good example, let's say, let's go to wolframalpha.com. Now what this is going to do is it's actually going to take, yeah, isn't that cute? It's actually going to take, this is now a cell within this cloud notebook that actually is embedded HTML. It could have been raw embedded HTML, but here I got it from the URL. And this is now looking at the Wolfram Alpha website, and it's just doing, I don't know what happened here, but hopefully it will wake up and come back and do something here. And it will, so this is now looking at this raw website and embedding it inside this cloud notebook. And I could as well take a YouTube video and embed it here and so on. So I can build up a very sort of rich experience there. So that's embedding things from the outside inside. And I could go ahead, by the way, and I could deploy this cloud notebook so that it shows up as a standalone thing without all of this framing around it. And then I could, within that deployed thing, I can essentially have iframed in any other asset. And from the other side, I could take any of the assets that we're getting from the Wolfram language and using this XML templating mechanism and so on, just to give a sense of how that works. If I look at the world of form functions is pretty complicated in general. There's a lot of functionality here. There's a lot of different ways that you can deploy them and so on. What they really do is they use what are called form objects. Form objects let one specify in great detail how a form is constructed. So they let one give, hints for a field in a form or mask a field in a form, those kinds of things. They let one provide, in general, a form layout function, which is sort of an arbitrary function to generate layout for the form. And that arbitrary function could be a template application from an XML template. I should mention when we come to interpreters, this is a very rich thing as well. The mechanism for interpreting input, there are many, many different ways you can interpret an input. You can say it's a phone number. You could say it's a, for instance, I could create something where I have, I can show you within the language how these interpreters work. These will be embedded in a form, but you could say something like, let's say street address, and now I could say, so that works. Okay. So that's now allowing us to, that will, if we put a street address as a field in a form, then we can people can type in a street address and it will immediately return the geo position associated with that street address. And so the same is true with just a huge range of different types of things. There are about 400 or 500 of these right now that you can use, and all of these can be interpreted using natural language. So for example, if I say interpreter, and I say, for example, well, let's say I could say computed city, and then people could enter something like, capital of Italy here as the name of a city, and then when it actually does that computation, it will go and it will give us the canonical entity associated with Rome, and I could say what the, for example, I could ask it the geoposition of that, and so on. So this whole thing flows through in that way. Can I integrate or link Wolfram Cloud with my private SQL server database and query it in the cloud? The answer is yes. You can use the database link mechanism from our that existed in our technology stack for a while. You will have to expose your database so that it can be connected to from our cloud. The alternative to this is that you can actually run the database in the cloud. We have a certain amount of that that's already here. We have a lot that's coming in the fairly near future with an ability to do things like that. One of the important functions related to this is a Wolfram Language function called dataset. Dataset is a mechanism for dealing with structured data. It's a very powerful mechanism that kind of combines SQL and NoSQL, relational and hierarchical database ideas, and lets you get lets you deal with data in a very efficient and powerful way, and with very large amounts of data. And kind of the concept with dataset. Let's see if we can find an example here. The concept with dataset is that you can, so you use semantic import. You can use semantic import to take something like a spreadsheet or an existing database and be able to semantically import it, dealing with all sorts of natural language constructs and so on in it. But you can also, once you have this in a data set, you can do all kinds of queries and so on it. But one of the things that's important about data set is there are different kinds of backing that a data set can have. It can be backed in memory, it can be backed from files, and it can be backed from an SQL database. And so the main mechanism that will exist for having persistent database type data within the cloud will be backing dataset with an SQL database in the cloud. That's not yet available, but will be quite soon. But for the time being, you can use database link and simply connect back to your database so long as it's exposed to our cloud. What will be happening, next question is, what will be happening to Mathematica, the desktop application? It's alive and well and advancing in leaps and bounds. Basically, the technology we have here simply enhances what exists there. The way that Mathematica will work is it's basically built now on the Wolfram desktop technology chassis. Its real emphasis is on doing local computations. All the stuff with data in the cloud and computations in the cloud will be available in small quantities from within Mathematica. The technology exists there, but that's not the primary model of usage for Mathematica. However, one of the things that's coming is, in the very near future, is an online version of Mathematica where you'll be able to seamlessly go back and forth between desktop and cloud. But I should say that the algorithmic advances that we've been making in sort of the core Mathematica area in recent times that exist now in the Wolfram language, I consider to be extremely impressive, and there's a lot happening in that direction. Somebody is supporting my idea of a computational thinking course. Thank you. It'll be a lot of work. I've said I'm never going to write another big book, and I've got to avoid this turning into something like that. Okay, can the user of a cloud form preserve state, i.e. create values that can be used in subsequent computations? That is if one wants to give the user a set of related tools rather than a single manipulate. Absolutely, the answer is you can absolutely preserve state. So anytime you save something, the way you preserve state is with cloud symbol or by simply putting something into a cloud object. Now, if what you're doing is to have forms that are used by many, if you have third-party users, if you have users coming to your form and you have multiple different users who have separately logged in, again, the same thing will just work. If from within their account, if you have exposed a form that they use and within their account, they're running that form from within their account. So whenever it creates a cloud symbol or a cloud object, that cloud symbol or cloud object is stored in their account. So they will get that particular instance of that variable back again. Okay, so examples provide powerful method of deploying relatively simple what-if analysis. Could one do a full site, say reporting with proprietary data mixed with Wolfram's curated data, multi-page, multi-user, contained within something that looks like a proprietary website? Yes, that is exactly the idea. You can build a lot of that with Programming Cloud. There will be some extra bells and whistles available in our data science platform, but yes, you can absolutely build that. And in fact, you can absolutely build all the dashboards. You can create something which has whatever pages you want. I mean, you can get arbitrarily fine-grained control if you want to. You can actually specify right down to the level of how the HTTP responses work. You can have redirects. You can build up hierarchies of pages. You can do all sorts of things like that. It's all available here. And yes, that's exactly what we hope and expect people will do with this technology. Next question is, what's the difference between Mathematica Online and Programming Cloud? It's really a difference in what's made easy to do and what the subscriptions and licensing models are set up with. I mean, when you put Mathematica online, it's really just a question of using notebooks in a cloud environment. Programming Cloud is really all about creating code and deploying it. The sort of the purpose, the workflow for Programming Cloud is you write some code, you put it in your notebook, you put nice comments in your notebook, you save away your code, but the real thing you're making is something that is deployed in the cloud for other people to use. It's really a tool for programmers, and that's sort of just a different workflow and a different objective than Mathematica. What if we already have, next question is, what if we already have Wolfram Desktop, Mathematica 10? Is there an add-on with Premier Service? So the answer is that this is a complicated web of issues. So getting to online, yes, there is an add-on to Premier Service to get to Mathematica Online. To get to all these deployment mechanisms, it depends what you're trying to do. If you're trying to deploy the next giant web company, your copy of Mathematica will not be the right thing to use to do that. You'll need a whole deployment. You'll need to get cloud credit for the deployment, and that's something that is more conveniently set up through the Programming Cloud. But there is from any one of our products, because they're all based on the same technology stack, from any one of our products, you can always get the pieces that you need to build up the capabilities of any other. But in the case of Programming Cloud, from within Mathematica, you will be able to do a few sort of toy deployments. But if you're going to start the next great web company, you need to be getting something that is based on cloud deployment and getting in kind of a track where you're buying and renewing cloud credits and all those kinds of things. The next question was, how can you control access to accesses your cloud deployed endpoints? I think I showed that already with permissions and so on. Will it be possible to cloud deploy an interface that manages files, upload to or download from the cloud? Yeah, you can do that. In fact, if I go ahead, if I say something like, let me do something here. Let me say cloud deploy of form function, and now let me say file name or something, arrow file, file name, I guess here. And now let me just use the file name here as the thing that I produced. Now, if I deploy that, what should happen here is I should get, oh, that's just a file name. That's weird. What I was expecting to get was a file browser here. That's odd. I think I have to read the documentation to know what to do here. Let me just see what happens if I go ahead and say that's an image. And I think then what it will do is it will ask me, see what it does. Yeah, okay. So here what I'm getting is a file browser that allows me to, that requests me to upload an image to be used. So yes, that's a seamless thing that you can immediately do, is be able to upload files there. Where will the data be stored is the next question. Well, so this is the cloud, and it's one of those modern statements that always sounds kind of silly. The data is stored in the cloud. You can always, one of the features of our cloud is you can always download. At any moment, you can always go ahead and just say download, and you could write a program if you wanted to. I mean, I could say, all of the stuff that, all of the usual kinds of things that you would expect work in the cloud. So you can go ahead and look at file names and so on. You can go ahead and move files. You'll be able to move files. In fact, you can right now move files between, cloud get and cloud put and so on. You can move files to and from the cloud. You can do that programmatically. So your files if you're using the cloud, the data will be in the cloud. If you can also move that data to the desktop and so on. Are we planning on providing iOS end user support? I already mentioned that all of this can be the Wolfram Programming Cloud. The things you deploy, there will be a Wolfram Cloud app that allows you to immediately access the things you deploy. When it comes to programming from a tablet, yes, you will be able to do that, and there will be convenient programming keyboards. I don't know how common that will be. I think it's a bit fiddly to be programming from a tablet, but we'll see how that plays out. But it will certainly be possible. You'll be able to access the exact same Wolfram Programming Cloud from within the Wolfram Cloud app on a tablet. You could also access it on the web, but it will be much nicer from within the app. Is there a way to do autocomplete in form fields? The answer is not yet, but it is coming. Is this webcast subject to an NDA, or can we tell everybody about it with great excitement? This is, as of today, this is all public information. This is good stuff. You know, it's all live. As I say, right now, Wolfram Cloud is live to the world. We'll be sort of making the full announcement in actually just a few minutes here. How is new knowledge added to Wolfram for public and private instances? So we have a huge knowledge base, and we have a large team that is adding to that knowledge base. It's used in Wolfram Alpha, and then in places like Siri and so on, which use Wolfram Alpha. It's also used in the Wolfram Cloud and in the Wolfram Language. And the thing that, I mean, it's a big effort to accumulate all of this data. We, our main goal is to go to primary sources of data and curate and sort of make computable all of the data. Every year we have a kind of data summit conference in Washington, D.C. in September, where lots of people who run all sorts of data repositories and so on come, and we talk about kind of this process of curating and making computable data. I think if there's a private cloud, okay, so a quite subtle question that you might be asking is, in a private cloud, how does data flow into the private cloud? So the answer is that a Wolfram private cloud, as it is normally configured, is a computational cloud. It's a cloud that is doing the computational operations of the Wolfram language. When the Wolfram language needs data, it has to call out to our knowledge base, and it's using essentially the same server infrastructure as Wolfram Alpha, and it's going, and essentially you can think of it as basically calling Wolfram Alpha to get that knowledge. And Wolfram Alpha is a big, hairy creature that is not something that can be virtualized as easily as our Wolfram private clouds can be virtualized. One can actually get Wolfram Alpha appliances, and there are a bunch of them out in the world at this time. Those are pretty sophisticated things that are actual physical appliances that run inside data centers and which have all of the data feeds available so that it's possible to have all of the data, the real-time data that flows into the Wolfram Alpha knowledge base is able to flow into your private Wolfram Alpha appliance. And that's a way that you can kind of completely cut off from our world, so to speak, and run all of this stuff. But that's a pretty sophisticated thing. And right now, those appliances exist at in a bunch of large organizations. Okay, can one make changes at the granular level to knowledge? Well, no, you cannot go and change, the population of a country or something. It's easy to write code that will override for your local operations any built-in capability of the Wolfram language. That's just the way the language is set up. Everything can be overridden. In terms of you can store your own data, your own version of country data, but you can't go and change the public version, which is probably a good thing. Okay, will it be possible to deploy hyperlinked notebooks so as to get documentation or a booklet on the web? Absolutely. This is, you just literally, you go in here and let's take that. I can go and say insert hyperlink, and we can turn this into a hyperlink. So there it is as a link. Are there plans to do a Wolfram language course like Codecademy and so on? We will certainly be doing a bunch of Wolfram language courses. I hope and expect that a lot of other people will do them too. Because we've been particularly interested in programming education, those courses will be pretty broadly accessible. We'll be doing ones for professional programmers, but also we'll be doing ones that are accessible to people who haven't done any programming at all before. yes, this comment that you make a comment that you can use the Wolfram Cloud to do the interactive part of doing course. Absolutely, that's the case. In fact, there's already designed, and maybe yeah, I'm not sure if this is out yet, but you can basically have a video in the top of the screen, and you can be working down below on your course. And one thing to know is, in fact, we have a course authoring tool that is not yet released. I'm not sure if I can do it. No, I can't do it. I don't have it here. That allows one to basically record videos based on, it's a convenient way to record videos based on doing operations in notebooks and so on. Okay, we are getting close to the end of time, and we've got, okay, I think I can probably get through many of the questions here. Okay, somebody's asking, I wonder if machine learning could classify questions that people are typing to help me. That undoubtedly, it's always fun to see what machine learning succeeds in doing. We certainly have, even in our built-in one of the built-in classifiers that we have is a sentiment classifier, and hopefully, if I say something like this, it will go ahead and at least give me sentiment analysis on that. Is there a guaranteed response time possible for tech support for the Wolfram Cloud? The answer is absolutely yes. At the enterprise level, there's a bunch of SLA mechanisms for dealing with those kinds of things. Okay, so next question. Your pricing model counts cloud credits, but a developer will deploy to your cloud. So are cloud credits charged against developer time, user time, or both? Okay, so what happens is your subscription as a developer lets you do all the programming and interactive sessions, within certain limits. It lets you do lots and lots of those. When you deploy, and when people are coming and using APIs that you've created, that's where the cloud credits start being used to determine how that works. So that's where it counts, and it's counting blocks of CPU time and data accesses, and also when you use external services, like for example, if you want to send a text message or something, there'll be a charge from the external service, and that's flowed through to cloud credits and so on. Will there be student discounts? The programming cloud is really intended for professional programmers. We think it's free to get started, and if you're a student and you're making and you're really being charged a lot of money in the programming cloud, that means you have a pretty serious piece of programming and perhaps website or whatever up and running, and then it doesn't really make sense to say you're a student anymore. What we have coming, a bunch of Wolfram Language capability specifically aimed at students and at programming education, and that will have a different pricing model. Is there any limitation of the complexity of a cloud object? Can I cloud deploy anything I can develop in Mathematica? The answer is yes. A cloud object is essentially just, you can think of it as essentially just a big expression, a big Wolfram Language expression, and you can put anything you want there. You can have you could have 100 megabyte, a gigabyte-sized cloud object if you want to. Okay, the cloud subscription is separate from the Premier service of desktop, or does one get a cloud level, the desktop license? It's really embarrassing. I don't know the full answer to that. The answer is that there is an option to Premier service to get the online version as well as the desktop version. I think you get a small amount of sort of a starter ability to use the cloud from the desktop version. I'm going to rush through some of the rest of these. Okay, any HPC support like OpenCL? The answer is okay. The answer is that there will be an HPC option for the Wolfram Cloud in general. In terms of GPU capabilities, that will probably be part of the HPC option because it's something that's part of the Wolfram language. But more interesting in the HPC option will be the ability to say, okay, now I want to run this in parallel across 10,000 cores. And that will be something where you'll be able to do that straight from, you'll be able to do that from your desktop session using the Wolfram Cloud or directly from the cloud. Is there a documented way to customize the Wolfram Cloud UI? In other words, to put different things around here? Not yet, but there will be. Are all servers for the Wolfram Cloud located in the US? I think as of today they are, but they will not be for much longer. And it will be possible to set things up. For example, if you have a virtualized private cloud, you'll be able to request servers wherever you want them. Will CDF be supported on mobile also? That's a complicated question. CDF, Cloud CDF will be immediately supported on mobile. Native CDF is a sort of huge technology challenge, but native CDF is on its way, not yet available. So, okay, asking about cloud symbol example. So all symbols in all cloud deployments share the same space. In your interactive sessions, that is correct. I mean, you can segment them in all sorts of ways. That's a complicated story, but in the most simple-minded way of doing it, yes. What can we expect from the performance of cloud computations versus local desktop? Depends how fast a computer you have. The machines that are being used for the regular cloud are as fast as any reasonable desktop. When we have the HPC option, one will be using sort of the fastest machines and then be able to parallelize from there. So I would expect with the HPC option, you'll see vastly faster performance overall. Where's the connected devices project going? Well, there will be a bunch of announcements coming soon about that. There's some exciting things in that direction. Not for today, though. What are the limits in memory, processing power, public usage of cloud objects? Okay, so depending on your subscription, you get allocated a certain memory limit and processing time limit. That's again, if you have a private cloud, those things go away. So the next question was about computation resources buying occasionally. That's exactly what will be possible with the HPC option. Let's see, can we set the cloud applications to run at our data center? Yes, for the private cloud. How secure is the Wolfram Cloud? So there will be a variety of infrastructures. Right now, this is primarily running in the Amazon cloud. And you'll be able to get options for example, HIPAA compliance and things like this. When you get a virtualized private cloud, you'll be able to ask for one with those capabilities. Did we just lose everybody? Okay, a question about private cloud. Would it run a specific OS, or could it be run in a different operating system? That is an interesting question. I do not know the answer to that. It certainly runs under Linux right now. I do not know the answer to that. I do not think, it will certainly not be trivial to run under a different OS. Whether it is possible, I think it's conceivable. It's the first time that question's been asked, so don't know. Good question. Can you generate a CDF report from the cloud and running CDF on tablet? The answer is absolutely. You can generate it from the cloud. You can generate it as a downloadable CDF. Running it native on a tablet, as I say, not available yet. Is this a beta? We are considering this a beta, although that's really just because it's really not. It's a very big, complex product, and it's not quite up to our perfection standards. For the next little while, we're going to consider it a beta, partly because we hope to get more feedback from people to help us fix all the things that aren't working correctly. But it's a very usable product at this time, and we hope people will start working with it immediately. Okay, can we address connectivity between Excel and Wolfram Language functionality? Can I use embed code to generate the VBA code that Excel needs? Very good question. Answer to that is yes. You'll be able to generate from within the embed code, can generate Visual Basic, which you can then put into Excel. Actually, there's a more sophisticated thing that we're hoping to do that involves actually having a plugin within Excel that directly calls the Wolfram Cloud. In addition, you'll be able to do embed code for form functions that will actually create interfaces that you can put into Excel. But one of the challenges here is getting all that stuff to flow through in a very clean way. What we intend to do is for many kinds of IDEs to have plugins that let you write code in the IDE and then call out and then use effectively embed code knitted into the IDE to create what you need to be able to put code in that will call the Wolfram Cloud. Can Cloud Deploy execute commands using packages that are encrypted within code? I think the answer is yes. Actually, we have a much more elaborate encryption system that is coming rather soon that we'll be able to use where that type of thing will be straightforward. But I think it will just work right now. I've not tried it. Let's see. Is it possible for the codes of a cloud object to interact with binaries built in another language, for example, a .NET DLL? Okay, so the answer is in the public cloud, you cannot do that. The public cloud has to be more controlled than that. If you have a private cloud, then absolutely you can connect the Wolfram engine in the private cloud to whatever external programs you want. Will you be able to call R code from within the cloud? I think the answer is yes. I think that should just work. I mean, anything that is kind of a controlled application, but it's not possible in the public cloud to just say, here's a binary, let me, you know, the question that was asked a little while ago about security in the public cloud kind of tells one why that's not going to be something that we're going to let people do. But in terms of things that are set up to be attached directly, that should be possible. And I think very last question, will it be possible to run CDF from within PowerPoint or Keynote? So I think the answer is, well, I mean, if you can get to a web page if you can effectively iframe a web page from within those, you will certainly be able to get to a cloud CDF. That's a good question. That's a good, and actually that would be a good thing for embed code to be able to do if there's appropriate plugin architecture for those systems. All right. Well, thank you all very much for coming, and you should be able to get onto the system and try it out for yourselves and let us know what you think. Thanks a lot. Bye.